Now let's do the next problem. In the given circuit, the switch is moved from position 1 to position 2 at time t is equal to 0. That means what this sentence means is that this is the circuit diagram, and here you can see there's a switch over here which has two positions, position 1 and position 2. Okay, and in the switch it was at 1, and then it moves at 2 at time t is equal to 0. So before time t is equal to 0 it was at 1. Okay, that's what this first sentence means. Before time t is equal to 0 the switch was in position 1, and after time t is equal to 0 the switch moved to position 2. Now you need to know where is the steady state condition. Here it says that the steady state condition has been established in position 1. That is, in position 1 only the steady state condition has been achieved. Determine I of t for t greater than 0. That is, find the value of I of t when the switch is at position 2. That's what this question means. This is the I of t. Okay, I have not shown I of t. This is I of t. This is the question. Okay. So here, if you see these kind of a circuit, first you need to understand is, in these kinds of a circuit which involves a switch, just think of it like this, that there are two circuits inside the circuit. That's how you need to think. Okay, there are two circuits inside the circuit. One circuit you are using to find the initial conditions, and the second circuit you are using to find the value. Okay, and the circuit that you use for the finding the initial conditions, that circuit is exactly when the steady state condition is being placed. So you need to understand in which circuit there is the steady state condition, and then from there you can find the initial value. What do you mean by initial value? Initial conditions, what I meant is that, you see, if you look at this inductor, right, this inductor, the Laplace transform of this inductor is nothing but an impedance whose value is Ls, and then there is an initial voltage across this, or there is a voltage source that represents the initial voltage across the inductor. It is represented by L into I of 0, where I of 0 is the initial current across the inductor. So if you want to find the value of this I of 0, you need to draw the circuit in which the steady state condition has been achieved, and then in that condition, in that circuit only, you can find the value of I of 0. Okay, now look over here. When is that steady state condition in this question? The steady state condition has been established in position 1, which means, like I said, this circuit has two circuits. This circuit has two circuits. One circuit is when the switch is at position 1. The other circuit is when the switch is at position 2. And the steady state condition, that the switch when it is in position 1, that is the steady state circuit. Okay, so I will draw that circuit first. That is, when or before t is equal to 0. You can either write like this, or you can also write at t less than 0. These two statements are correct. You can write any one of these two. I preferably write like this: at t less than 0. That is at t before 0. Okay, that's what this means. So in that case, it's written that the switch is moved from position 1 to position 2 at time t is equal to 0. That means before time t is equal to 0, the switch is at position 1. That's what it means. So if the switch was in position 1, then this will be the circuit. That is, right, this will be the circuit. And one more interesting thing is that it says here that the steady state condition has been achieved in position 1. That is, the switch is in position 1, right? I have drawn the circuit in such a way that this switch is position 1. So where is this resistor? This resistor is missing. Why is this resistor missing? Because this part of the circuit is open. No current will flow through it. That is why this resistor is removed in the circuit, because there is no resistor over here, because the switch is at position 1. So therefore current will flow on this direction. That is, this resistor is connected to nothing. That is why this resistor is open. So that's why I have not drawn this circuit, and the remaining circuit will be like this. And also you have studied that in a steady state condition, the inductor act as a short circuit and the capacitor act as an open circuit. So this inductor, there is an inductor over here, and if this inductor is in steady state condition, there is nothing but a short. It will be shorted. If you want, I will just put 2 points over just so you understand that there was an inductor over here, but now it is shorted. Okay, and the current across this shorted path is what you call as I of 0, which is what you need to find. Okay, that is what you need to find over here first. So this is the circuit. Here there is 1 ohm. This is 10 volt. So this is a simple circuit, right? There's nothing over here, just a voltage and a resistor, that's all. So in that case, what is the value of I of 0? I of 0 is equal to V by R, which is nothing but 10 by 1, which is equal to 10 amperes. Therefore, I have discovered that I of 0 is equal to 10 amperes. Now, I can apply the transformed impedance to the circuit by after putting it switch 2. Okay, so at now, after t is equal to 0, comma, okay, or I can say at time t greater than or equal to 0. You can write like this also. Okay, in that case the switch is at position 2, right? Because that's what it says here. The switch is moved from position 1 to 2 at time t is equal to 0. So initially it was at position 1, that is this circuit. Now it will be at position 2. Position 2 means, then look at over here, position 2 means it will be in this position, right? So it will be connected to this resistor, right? It will be connected to this resistor, and this portion will be removed, right? This portion will be open. This part of the circuit will be open, so no current will flow through it, so this portion will be removed. So this is the circuit. One ohm, 1 ohm, 1 Henry. Okay, this is the circuit when the switch is at position 2. Okay, just we will make you understand. I'll say I'll write like this also. The switch is at position 1. Here I can say that the switch is at position 2. Okay, just so you will understand what it means. If you want, you can write this also, just so that you will understand what it means. The switch is at position 1. So position 1 means it is connected to the voltage source. Position 2 means it is connected to the 1 ohm resistor. So here the reason why this 10, I have not drawn the 10 volt is because this 10 volt part of the circuit is open, because the switch is connected to 2. The switch can be connected only to one of the position at a given time, right? So here it was connected to 1. The switch was connected to position 1. Here the switch is connected at position 2, which means that's how it happens in all the circuits. That is, one of the portion will be removed, the other portion will be there. Okay, that's what it means. So at time t is equal to 0, this is the solution. This is the circuit when the switch is at position 1, or this is the steady state condition, because it's also written here that the steady state condition has to be established in position 1. That is why in this circuit I have shorted the inductor. Okay, because under steady state condition the inductor becomes a short circuit and the capacitor becomes an open circuit. And you need to find the value of the initial value. Initial value can only be found when the circuit is in the steady state condition. Okay, so now what I'm going to do is I'm going to apply Laplace transform to this equation. Okay, I'm going to apply Laplace transform to this equation. So the Laplace transform of this will become the resistor will become a resistor itself, in which the impedance is 1. This resistor will also become the resistor itself, which means the impedance is also 1, but the inductor becomes an inductor with a negative voltage, right? With a negative voltage. With a negative voltage. This is the transformed impedance of this circuit. Okay, and this is the Laplace transform of this circuit. Okay, and in the circuit, this is supposed to be Ls, right? ls, but here L is equal to how much? What's the value of L? 1 Henry, right? 1 Henry. L is 1 Henry, which means ls is equal to 1s, or simply s. And over here it is the value of this voltage is supposed to be L into I of 0. L into I of 0. But what is the value of L? L is 1 Henry. And what is I of 0? I of 0 is 10 amperes, which means the value of this is 10 volt. So we have the impedance is S and the value over here is 10 volt. Okay, this is how we find. Now what you need to do is simply find the value of I of S. This is the Laplace transform, right? So it's I of S. You need to find the value of I of S, and then you simply take the inverse. So what is the value of I of S? According to the circuit, the equation is applying mesh analysis. I of S is nothing but 1 plus 1 plus S, right? 1 plus 1 plus, it is touching all three impedance. 1 plus 1 plus S is equal to, and this current is flowing out of the positive terminal of the battery, which means it is plus 10. This is the equation. Or in other words, I can say that I of S is equal to 10 by S plus 2. Right? The current of this is 10 by S plus 2. So in that case, I of t is equal to 10 into the Laplace inverse of 1 by S plus 2. Or in other words, it is 10 into e raised to, this is frequency shifting property, e raised to minus 2t, okay, into u of t. Okay, for t greater than 0. Oh, that's why I don't have it for t greater than 0. This, you can simply write this u of t. This is the answer. Okay, this is how we do the problem.